Hello everyone, welcome to this video. So in previous video, we already discussed about regression equation, if you remember. So we already discussed about just a minute. Yeah. So we already discussed if you have any equation, suppose there is a one dependent variable and one independent variable. So our prediction equation will be W naught, that interception, and the coefficient multiply with your dependent independent variable, maybe that is rate of feature one. So in previous video, we already discussed about this equation, how we will get this equation, and even we already completed how we are able to find this W0 and W1 value. If you're able to recall this, we already discussed that. If you calculate all those calculation, you will find W1 is equal to nothing but covariance of your feature and that basically the dependent variable and your independent variable divided by variance of your independent variable. So you are able to already do that calculation. We are already completed the maths behind this. Now let's talk today in this video very important topic. Suppose we already calculated this. Now you have this equation. Mathematically, this equation you already have. Suppose so maybe you have this equation yp is equal to your w naught and w1 into feature one. Suppose you have this equation. Now suppose you want to predict something, but you don't know how much accuracy of your model, right? Especially for the regression equation. For that, there is a term called COD, that is coefficient of determinant. It's called R square. I'm going to talk about this today. This is very, very simple thing actually. This is not exact accuracy, but I will explain in the class today. So R squared is equal to basically the explained error divided by total error. It's called explained error divided by total error. I will explain all these things. What is total error? What is explained error? So this will be the value. Okay. And end of the class we'll come to know that R square value basically less than is equal to 1 greater than 0. So this value looks like this. So it means if your R square is near to 1, it means your model is more fit, right? It's going to give you better accuracy. If your value is less, like maybe zero point 0.1, zero point 0.2, it means less good model, less fit model. So that is not going to work. Okay? So we'll talk about this, how you come to this equation, how you come to this equation, and how we are seeing this. So I'm coming to that. Let's start from beginning. So as you guys already know the regression equation, so I'm not already discussed in the previous video. So let's go into more detail. Okay. Okay. So I'm explaining like this. Just give your attention here. Suppose I have this. This is my x. So let me delete this. Suppose I have this one line here, okay, and there is another line, maybe this one. Sorry. Okay. Suppose this is my x. X means like independent variable, and this is y. This is dependent variable. Suppose this is my average line. This one. This is my like y bar. Is my y bar. So this is the basically the average of dependent variable, and this x-axis is basically the independent variable. Okay. Suppose there is a point here. Let me change the color first. Suppose I have point x1, right? For x1, definitely there will be y1. Suppose this is my y1 for this respective x1. Maybe this is my y1. So this is the point for x1, y1. Okay. This is basically x1, y1. Okay. Now see, this is the average line. Okay. Suppose for this particular point, this definitely if you plug this value in your this prediction equation, this x1, definitely you'll get some yp1. So maybe this yp1 is here. This is my x1 comma yp1. So definitely there is a loss here, right? So for this x1, I have this prediction one. So basically, from where I'm getting this prediction from this particular equation, and we already in previous class discussed how to get this equation, right? See, it's very important thing here. This is called your SST. This is called SST means total sum of square. This is called SST. Total sum of square means the gap between the average, this is average y, and the real y is called SST. What is the gap between the average y and the real y? See, SST is the total sum of square because there is not possible then you are going to your model is going to wrong, even worse than average because anyway we are able to say average, right? This is called SST. This is very important thing. This is this point. This is right. If you remember in previous video, even if we will try to decrease this value, right? It's called SSC, error sum of square. Right? This is a gap, right? Your prediction and your real value gap, true value gap. So generally we do a square and all the calculation in previous video we already did this. So this is your SST and this is your SSR. This part. This part is called SSR. SSR means regression sum of square. This is also very important thing, right? So this point is SSR, regression sum of square. This is SSC, error sum of square. This is SST. So here you can see SST is equal to SSC plus SSR, right? So if you remember in our last video, we talk about this SSC and we try to decrease this as much as possible, right? So this is my SST. SST is equal to SSC, error sum of square. This is the real loss, the loss between the prediction and the real true value. And the average and the prediction gap is called SSR, regression sum of square, right? Now, from this image, you are able to see what is SSR, what is SST, what is SST. SST means just gap between the prediction and average value. This is very simple, right? So, if you remember this formula, just I wrote when I starting this lecture, the COD, coefficient or determinant, that is called R square, right? R square is basically explained error divided by total error. The total error is this term, right? This term is total error. Just a minute, let me change the color. So this part is your total error, right? Not is explained error. Right? This is your explained error. That's why it is called SSR divided by SST, right? See what will happen here. If you want to increase your R square, you have to increase your SSR, right? So whenever your SSR is just increasing, your SSC is decreasing. And we are looking for that. We always want as low as possible SSC. So if you want to decrease this SSC, definitely you have to increase this SSR, right? That's why this is R square. But see, if SSC is 0, that is not possible anyway. But suppose it's 0, ideal case, then what happen? SST is equal to SSR. In that case, this will be cancelled out. R square become 1. This is the, ideal case when your SSC is 0. That time your R square is 1. This is the actually fit model, right? This is actually, and anyway, practically it is not possible that SSC will be 0. So that's why you got this formula, right? R square is equal to SSR divided by SST. So if you want to increase R square to increase the SSR, so whenever you increase the SSR, automatically by default SSC will decrease. So even you can say in opposite way, if you decrease your SSC, that is error sum square, And even in our previous video, this is our agenda. If you try to decrease this, and when we are decreasing this, try to find the minimum for that value, then we got this W0, W1 in the previous video. So if you want to decrease this SSC, definitely your SSR will increase. So once your SSR will increase, your R square will increase. Okay. So this is the actual equation, right? Now let me remove all these things. Give me a minute. Let me delete all the things. Okay. So now let's select the pen. Okay. So we got this R square COD coefficient of determined basically SSR divided by SST. We can also rewrite like this SST minus SSC divided by SSR. This is also okay. Sorry, this is SST because the SST formula is nothing but what? SSR plus SSC. SSR is equal to SST minus SSC, that's I put here. So if you recalculate this will become like 1 because if you divide the 1, sorry, minus SSC divided by SSR. Okay, now we got this formula. So even from this formula you can see we are always looking to decrease this SSC. If you able to, it's not anyway possible, but suppose you are able to decrease this is equal to 0, automatic again now R square will become 1. So we're always looking for this. We know this is not possible that SSC will become 0 and we got R square equal to 1. But as low as is possible, we can do this. At that time, this is SST, not SSR. Sorry. So as much as low we can do this, we got R square, like as much as possible. So now we got this. Even yesterday in the last video, we'll try to decrease this SSC. So we try to find the minima of this SSC. So we are do the calculation like that. So when we try to get this minima, for that we calculated this W0 and W1 for that equation. Today again, if you this will be the minima, that R square will be maximum. So right, so this is not just accuracy basically. What is actually this is the see theoretical meaning. Suppose you got R square is maybe 78%. So in that case we can say like 78% variability in total in target basically the dependent variable. So you can say like this 78% variability in dependent variable can be explained by linear relationship between your dependent and independent variable. So basically, the meaning of R square is like suppose you got 0.78, means 78%. So you are able to explain your target or maybe your dependent variable using independent variable. This is the basically the relationship you are getting 78%. Right? Suppose you got maybe 0.99, it means 99% you are able to explain your target. Suppose you have a data like this and this is a target feature. So this target can be explained using this feature 99%. This is the meaning of R square. Okay. So in this particular video, I'm trying to explain to you what is R square, what is coefficient of determinant, how we try to find this, the whole the equation and theoretical meaning of this. So in previous video, I already talked about how we generate the regression equation mathematically. Now in the next video, we'll try to use the package for this. We'll try to use the package, how you'll get the regression equation. Then we will use this that particular package to find the R square equation. So in the next video, I will talk more about the Python package. Okay. Thank you so much for watching this video.